Hey everyone, Tony Burke here. So we're going to do a quick demonstration of Ansible. Now, Ansible is one of the most, in fact, it's the most popular open source multi-vendor network automation platform. It works with Arista, it works with Juniper, works with F5, works with a lot of the different vendors out there, and it's probably one of the most important skills to learn today if you're going to be doing automation in the networking world. In the Arista world, we can use it directly with EOS devices, or we can actually use it in conjunction with CloudVision. But we're not going to do that here. We're going to do the simplest implementation of Ansible that you can do. Ansible can get pretty complex. There can be a lot of moving parts to it, but we're going to reduce the number of parts here to just 3. So we're going to do Ansible with just 3 files. We're going to take a look at these 3 files. The 3 files that we're going to do is a playbook, a config file, and an inventory file. So the first file we're going to look at is the Ansible config file. It's just 4 lines, keeping it simple as possible. The first line is defaults. That just means that everything, all the settings here are going to be for everything. We can get more specific later, but this is all we need for now. We're going to find our inventory file. You always need an inventory file with Ansible. And we're telling it that we're going to find it in our current directory. So that's what the / means. And it's going to be the YAML version of the inventory file. You can actually do inventory files in 2 different formats, either INI, which is more of an old-fashioned Unix style config file, or you can do it the more modern YAML file. That's what we're going to do here. The next line is host key checking. And this is... if you have not connected to an SSH host before, or you haven't, the better option is to import the host key into your system. You're going to get this particular warning. Oops, not that warning. This particular warning right here. So the authenticity of host can't be established. So we've never seen the system before. We don't know if it's a man-in-the-middle attack, etc. Most people ignore this. They typically set up a system. And they do that. It's kind of like a self-signed certificate. We can't guarantee the authenticity of the host. Ideally, like I said, we're going to get the keys of the hosts, and we're going to distribute them to whatever clients that we're going to have. But we almost never do that. So we're going to go ahead and say, just don't worry about it. And it's like typing in yes here. Now, you may or may not want to do this in production. We're going to do this in this lab environment. It doesn't really matter. If you got this warning when you ran Ansible, so if Ansible was not ignoring the host key, if it was not ignoring the host key and you got this warning, then Ansible would not be able to run against that system. And finally, the last option we're saying is gathering is explicit. Gathering is, it's called gathering facts. Every time Ansible runs against a particular host, it's going to try to gather some facts about that host. These are things like what's the host name, what CPUs are installed, or how many CPUs, how much RAM, network interfaces, what they're named, what they're configured with, etc. We don't really care about most of that when we're running against network devices, at least not usually. And we're not, and it's collecting information about the Linux underpinnings of EOS. It's not really useful in most cases to us. Ansible was originally meant to be run against servers. It was a server automation platform, but it's grown since then. And this is showing the server roots. Like I said, we don't care about that. It takes an extra couple of seconds to gather those facts, and we're just saying, don't worry about it. We don't need it. It's not useful to us, and we're just going to speed things up along. The playbooks will run faster this way because it doesn't take the time to actually pull that information. So the next file we're going to look at is the inventory file. So the inventory file, in Ansible, you have to have an inventory file, and it tells Ansible what devices that we're going to be running against. In this case, we've got the root, and that's all. These are all the devices, and we've got some variables for all of our devices. And that's going to be network. For the first one is going to be Ansible connection is network CLI. We're going to be running Ansible directly against the EOS devices, which is actually not that common anymore. Most of the time today, we're going to be running Ansible against CloudVision, but That gets a little bit more complex, and I wanted to do a demo where we can just see some of the foundations of Ansible, some of the basics of Ansible. And to do that, we're just going to run it against the EOS device. If you're running it against the EOS device, we have two options. We can go in through the CLI, or we can go in through the eAPI. And the eAPI is just a JSON RPC wrapper for the CLI anyway. And so they both have the exact same functionality. The difference here is that we have SSH keys installed on the hosts. So this particular Linux system right here, this is known as the Ansible control node. And it's typically a Linux system. It could be Windows, could be Mac, whatever. But it's almost always Linux. And we actually, there's a private key installed on private key on this system, and some public keys were generated from that private key. Because we've installed the public keys on the various spines and leaves, we can SSH into a leaf without a password challenge. So this is a special setup that we did on the. You can do this too. The special setup that we did on the leaves and spines on the EOS devices. So that way we don't have to put a password into the inventory file or anywhere else in Ansible. If you're going to be using the eAPI, you need to provide a password somehow, so you can put it in the file. You can also prompt it on the command line, or you can in the file you can say use Ansible Vault, which is a encrypted storage system, so that you run the playbook. It says what's the vault password. You type in the vault password. It unlocks the vault, gets the passwords out of the files in there, and then you can runs the playbook and then closes the vault when it's done. So this is the simplest way, I think, at least in this particular environment. We're just going to use the CLI, which is connecting via SSH. The user account we're using is Arista. The network OS is EOS. Ansible Become. Become is it's a overall term used for becoming a super user, whether it's sudo or su in a Unix system, or here it's enable. So we want to become the super user. How do you do that? Use the enable command. Although I don't know if we need these options, because the way these accounts are set up, they go right into enable. So I'm not sure we need it, but we'll leave it here. And the next one is where do you find Python? So Ansible is Python based, and it needs Python. You must have Python installed on the Ansible controller. You don't actually need it. In our case, you don't need it installed on the remote systems in EOS. Some other implementation, if you're doing Ansible against like a Linux host, then yeah, you need to have Python installed on the other side typically. But we don't. We just need to figure out where it is locally. Next, we have two groups. So alls is a group, and then we have two children, spines, and leaves. Hosts here, we have spine 1 through 3. That's what that colon is. This can be really handy. So instead of typing out spine 1, spine 2, spine 3, we can just say spine 1 colon 3, which does, we're telling it about spine 1 through 3. Same thing for leaves, leaves 1 through 4. This is what our topology looks like. We've got 3 spines and 4 leaves. We have 2 border leaves. We're not going to use those in this lab. And we've got 2 hosts, and generally speaking, in these lab environments, these hosts are actually EOS switches, but they're in there to be. We can configure them as if they were hosts. We can put IP addresses and default gateways on them and so forth. I don't normally include them in network automation, because these hosts would not be a part of network automation. They'd either be configured manually by a system administrator or virtualization administrator, or they'd use whatever they're using for their automation platform, which may or may not be Ansible, but wouldn't be controlled by us, the networkers. So we're just defining these 7 devices. If I wanted to say, like, let's say I wanted to do every odd leaf, then I could do 1 through 4 count by 2, so that we would be 1 and 3. If I wanted to do the evens, I would do 2 through 4 count by 2, so that would be 2 and 4. But we're going to do 1 through 4. Okay, so we've got our inventory file. Again, it's written in YAML. And then finally, we have our playbook. So a playbook is a YAML file, And the playbook will have a number of plays or have one or more plays and each play will have one or more tasks. Here we've got it as simple as possible. We've got one play and one task. So for a play, the minimum we need is the host that we're going to run it against. We're going to run it against all of our leafs. So this is the group of leafs, and that was defined here. So that'll be leaf 1 through 4. We'll give it a name. We don't actually have to give it a name, but it really helps to have a name. And then we have tasks. So this is a list of tasks. The first item in the list, we've only got one item, is create the VLAN. We're going to use a module, an EOS module. So this is arista.eos. That's the namespace. And the particular module we're going to use is EOS VLANs. The config for that here is the VLAN ID is 20. We're going to call this DMZ, and the state is active. So these are the minimum requirements for this. Now, how do you format? How do you know what is available? Well, we can look it up in the documentation. So this is the Ansible documentation for this particular collection. There's 3 collections that we use in the Arista world. There's arista.eos, which is what we have here. This is for Ansible interacting directly with an EOS switch, whether it's a virtual switch, physical switch, or containerized switch. We have Arista.CVP, which is Ansible interacting with CloudVision. And we have Arista AVD, which is a collection of playbooks, modules for creating configurations and some other stuff. But we're going to use the simplest one, which is Arista EOS. A little bit of a fun fact. Well, Arista.CVP and Arista.AVD is maintained by Arista. Arista.EOS is actually maintained by Red Hat. And we've got all these different plugins here. These are good for discrete configurations for part of the configuration. So it doesn't do the entire configuration. There's some gaps here. For example, there's no VXLAN part. But if you need to do what I call supplementary automation, supplementary configuration, you're still doing things manually. You're still configuring devices manually, logging into a device and doing config mode and typing in out the commands. But you need to do something across a large number of devices. You can use this to supplement your manual configuration. So we're using the VLANs module, and you can look at the documentation and the examples to figure out what type of information that you need to provide the module. And on the left here, we can see some of the other modules that are available. There's Google, HPE, Mellanox, NetApp. We got some of the other networking vendors here. We got Cisco, F5, Fortinet, some others. But we're using the Arista ones, which again, these ones in particular are maintained by Red Hat. So we've got the very basic information that we need. Let's go ahead and log into Leaf 1. Oops, already logged in. Show VLAN, and we see we just have one VLAN. VLAN 1, the default. So let's go ahead and run this playbook and see if it works. So make sure you're in the right directory. The command is Ansible playbook, and you just specify the playbook that we're going to run. It's running the play and then running the task. And when you see something in gold, that means it's made a change to the device. It looked at the device, found that VLAN 20 wasn't there, and it added it. So we changed 4 devices. So let's go into Leaf 1, and I'll type in show VLAN. It'll just report back. Yep, there it is, VLAN 1, or VLAN 20 rather. Let's check out Leaf 2. Same thing. Leaf 3, and Leaf 4. If I run the command again, it's going to find that the VLAN that we've stated here, our intent, is already implemented, so it doesn't change anything. It just says, okay, we're good. It is what it said it needed to be. There's a fancy word for this that Ansible uses. It's a database transactional term called idempotency, which basically means that I can run this playbook as many times as I want, and this is the state we're going to end up in. If the state's already there, it's not going to make any changes. So you should be able to run it multiple times without having a different outcome, as long as the state on the system that you're running it against hasn't changed. So this is Ansible with just 3 files. Now, I'm going to put this all into a GitHub repository, and I'll put together some files if you want to play around with this. This was using the level 3 labs, but this should work with any of the other level labs. If you want to play around with it, I encourage everyone to take a look, and thank you for watching.